Hey everyone, good to see you back. Today we're going to go and look at some Azure Machine Learning. This is not really Azure Machine Learning. Azure is just the platform we're going to use to do some machine learning. We are going to take a data set, and our data set is actually going to contain information about used cars. And what we're going to do is we're going to create a pipeline within the Azure Machine Learning platform to be able to actually try and predict prices of future used cars that we might input into the system. So by using our existing data, we can then decide on how to price a car in the future. It's really interesting stuff, and we're going to go and look at a few of the different concepts of machine learning along the way and discuss some of the language that's actually used with Azure Machine Learning. So let's get into this, and let's start off with a whiteboard explanation. So machine learning, or ML, it's been around for a very long time, but we're really kind of pushing this forward now with the advantage of cloud and the amount of compute power we actually have available to us. You might not need to be a machine learning scientist or a data scientist to understand this stuff, but we need to have a general kind of understanding of how it sort of works. So what we're going to do today is we're going to actually grab some data. And this data is going to be data that contains information about cars. Now, what this is going to have, it's going to have information like the model of the car and the size of the engine of the car, things like the age of the car, and a whole bunch of other data inside here. And we're going to also have another column called price. And this is the column that we're actually going to use to predict. Now, this is going to have various different bits of information, the model, the engine, the age, and we're going to have existing information in this price column. So 1,000, 2,000, 3,000, and so on and so forth, depending on what the car actually is. And what we're going to do is we're going to actually kind of take this data and we're going to ingest this data into the system, and we're going to build a machine learning model from this data. Now, a machine learning model is kind of a bit black box, okay? Not black box. In the sense that you don't really know what's going on inside this model itself for its prediction. In fact, neural networks are very much black box. But once we've constructed a model based on this data here, we can go and start to predict price. So we can get into a situation where we can actually input new data into here. So we can input a new car model with a specific age and a specific engine size. And what this is going to do is it's going to be able to output an estimated price based on the information that we have trained this model with. Now, let's break down some more of these concepts first. So let's go and break down some data down here as well. Let's just screw this off over here and start with a new section. Now, one of the things I want to talk about here, and one of the techniques that we're actually going to use within this demo, is a concept called regression. Okay? Now, I know my writing is not particularly great, but you can still read that, regression. All right, so let's do a little example here. What about if we've got a very simple table of data? We've got seasons and we've got viewers, and we want to plot this on a graph. So we might plot season on the x-axis and viewers actually on the y-axis of our graph. So this is all going to be really, really rough here, but it's just a proof of concept at this point. So our seasons down here is plotted across this x-axis down the bottom. So it's going to be season 1, season 2, season 3, season 4, and season 5. And then on our y-axis, we're actually going to see the amount of viewers. So this might be looking at these individual plot points. So season 1 up here might be on the y-axis of 19. So let's say that this actually axis up here is going up from maybe about 10 up until probably about 50 at the top. But that's perfectly fine. So season 1 had 19 viewers. So that's around about here. Season 2 might have 17 viewers, around about here. Oh, drop that down a little bit more. This is very, very rough. Season 3, we've got 20 viewers. Season 4, we've got 29 viewers. And Season 5, we've actually got 31 viewers. So actually going up here at this point. So looking at this plot, we've got two actual variables. Now, there is some different concepts that they use within machine learning, or different ways of describing things. What we've actually got here is we've got a scatter plot, a very simple 2D scatter plot in this sense. We've just got X and we've just got Y, these two variables down here. And we've also got another thing. We've got something that says dependent variable and independent variable. Okay, so Y represents the dependent variable and X represents the independent variable. So let's have a look at this one. Y is set to the dependent variable, and X is actually something called the independent variable. Now, these concepts come up all the way across machine learning when you start looking at different models. It's all the different ways that it's actually named. So it means that X here, season 1, is actually dependent, sorry, X here is the independent variable, and Y, in this case 19 viewers, is dependent on X. So if we wanted to actually come up here and make a prediction, maybe we wanted to predict, in this sense, what season 6 is actually going to get. Now, what we could do is we could actually use a technique called regression. Or in this sense, very quickly, we could use something called linear I can't spell. Linear regression. So to predict this, what we might do is we might actually draw a line. Literally take this ruler over here, move this around a little bit. I can't move this around. Rotate. Rotate, 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 rotate. Okay, it's not letting me rotate. Let's get rid of the ruler. And we'll try this again in a bit. So maybe we can take a line here and kind of draw a prediction. We can see a sort of a trend line going up here, but if you wanted to draw an actual trend line through here, it probably looks something along the lines of this. There is a mathematical calculation you could do for this, but this is linear regression. And by actually figuring out how to draw this specific line, we could actually figure out exactly where to go and put this plot point for, in this case, season 6, which would be roughly about here. Now, the data that we're going to work with in our machine learning model in a moment is roughly the same as this, but we're not going to be using just an X and Y coordinate. We're actually going to be using multiple coordinates to do the same thing, but we are still going to use this technique of regression. And regression, in this sense, basically equals prediction. In this case, we predicted where season 6 might be on this scatter plot. And in here, we're actually going to use regression to go and build our model so we can actually start to predict prices on our cars based on inputs that we actually give it. Now, if you're curious about the maths for regression and actually how to draw one of these lines out, like this specific line here, well, the maths looks difficult, but in reality it's not that hard. Let's just draw the formula out. The maths for actually drawing linear regression is actually y is equal to bx plus a down here, in the sense that y represents the dependent variable, b represents the slope, x represents the independent variable, and A is the point where the hyperplane crosses the y-axis. So in this case, this point here would be A. This here, dependent on the actual angle of this slope or the steepness of this slope, is categorized as B. So there's A and B down here, and then Y and X are listed accordingly. And with a little bit of mathematics on top of this, we can produce our linear regression points. So that maths to calculate, in this case, the 2 points here, to calculate A and to calculate B, is actually A is equal to the sum of Y multiplied by, this is not going to look very great, but deal with me on this one, and the sum of X squared minus the sum of X multiplied by the sum of x multiplied by y over n, the sum of x squared minus the sum of x squared outside the brackets. So that will calculate A, or more to the point, calculate the position where the hyperplane actually crosses the boundary of y. If you want to calculate B in this sense, B, or the slope, is equal to n, and the sum of x and y minus the sum of x and the sum of y over n and the sum of x squared minus the sum of x squared. Now that looks quite complex, but if you look it up and actually start replacing things here, it's not actually that bad. When it means the sum of y and the sum of x squared, it's literally the columns here of x and y. That's all. That's the sum of all those columns. So let's drop back into describing what we're actually going to do here in our machine learning model inside Azure Machine Learning. Right, so things that we actually need to build. We are going to build an Azure Machine Learning cluster, and this is actually going to project into the Azure Machine Learning Studio. Now, there's a fun thing in Azure Machine Learning Studio called pipelines. And within these pipelines, what we're going to take is we're going to take a pipeline and we're going to take some data, the existing car data. This existing car data, we're going to build a pipeline with it. And this existing car data, we're going to do a number of things to it. One of the first things that you always need to do to data, though, is actually clean that data. Because big blocks of data, big blocks of CSVs, they might have missing values, might have values that are really out of range. If you start collecting data from anywhere, maybe you're collecting it from surveys or a big database, some data points are not going to be perfect and might throw the model off. So the first thing we need to do to any data that we're actually importing and trying to build a model from is we need to go and clean that data. So we're going to filter some information out of that. The next thing we're going to do, after we're going to clean the data, is we're basically going to select the data that we're actually going to use for training and the data point, or the data column, sorry, that we're actually going to use for prediction. So in our points, what we're going to use, prediction. So we're going to use this column for price. You'll see this in a moment when we actually pop up all of the data columns itself. So we're going to select off the data itself that we're going to use to train the model and the thing that we're actually going to use to train it with. Now, one of the main things that we need to do is when we actually build a model and we actually construct this lovely thing to be able to predict prices, we need to be able to test it. We need to be able to make sure this model is actually going to work. So all that lovely data that we've got, and we're going to have all this data in a huge table, we need to split it. So the data that we've actually got, if we can imagine a big table of CSV data, we actually need to separate that. And we need to separate that on about a 70-30 split, or 70-30 split here, for data that is actually going to be used here for training the model, and data that's actually going to be used for testing the model. So, for example, our data, just to break it down and make it really, really, really simple, okay? So we have car A, car B, car C, car D, car E, okay? And we have certain prices for each of those. So price of 10, price of 20, price of 30, price of 40. What we're going to do is, because we know that this value here is actually correct, we're going to split this all off. So we're going to say, look, use this to go and build this magic black box model. All right. And once we've built this magic black box model, what we'll do is we'll actually input some test data. And our test data in this sense is going to be E. And you're going to go and say, okay, predict what the price is from E. And if the model spits out 40, we know that 40 was the correct answer and we can mark that correct. Or, point being is, what we can also do if you extrapolate this a bit further, is the model might not spit out absolute perfect answer each time. The model might spit out, for example, 39 rather than 40. And in this sense, we could say that this is actually a percentage of accuracy. So by doing this a multitude of times and actually taking our data set, our known good data, and splitting this into 70-30 and using 70-30 for training, and 70% for training and 30% for testing, we can evaluate if our model actually works or not. So once this is actually complete, we have this model, this little black box. How does it actually get deployed? Well, in the sense of Azure, it's very, very easy to deploy one of these things. You've got a couple of ways of doing it. You can go and deploy it to an Azure Kubernetes service because a model is going to be a container, or we can deploy it in the sense that we're going to work in the demo, we can deploy it to an Azure Container Instance. Once it's deployed to an Azure Container Instance, you can actually communicate this and get inputs and outputs from it. So you can communicate to this thing via essentially REST. So we can go and fire JSON data at one end of this Azure Container Instance, and at the other end, we're going to get an output. In this sense here, we could actually fire at it our test data of E and get an output of maybe 40-ish, okay? So remember, this is doing prediction. It's not going to be perfect. And what we're looking for, especially when we're testing this model and testing the data in this model, we're looking for accuracy, or a level of accuracy, a good level of accuracy, but maybe not an absolute perfect level of accuracy. So let's go get on with the demo and actually have a look at how to actually deploy this whole thing in Azure Machine Learning and actually do some regression testing, i.e. some prediction on an existing collection of data, or an existing collection of data that contains car pricing. So let's start out here in our Azure Machine Learning Workspace. I have one already created. I will do a video on how to build one of these later on. But for the moment, I'm going to launch the studio. And we have lots of exciting stuff here in the Azure Machine Learning Studio. Everything from being able to create an Ask Wikipedia bot, to shortcuts for building notebooks and training models and doing all sorts of fun stuff down here on the left hand side. We're going to go through a few of these options, but today we're going to go and have a look at exploring regression with the Azure Machine Learning Designer. Let's go start off with building a compute page. So down here, or compute node, let's go down here into compute clusters and compute instances. And what we're going to do is we're going to create a new compute cluster down here. We're going to add a new one, and we're going to select a few different types. So notice we've got GPU, CPU types, dedicated, low priority, and the location. You need the availability to be able to deploy one of these clusters. You need the amount of vCores on your subscription. If you don't, it won't be able to deploy. So we're just going to select a CPU type, dedicated, and we're going to do a basic DS11v2, 2 cores and 14 gigs worth of RAM here. Now the compute name, I need to enter a unique name, so I'm just going to call this Chromic Cluster. And the minimum number of nodes is 2, and the minimum number of nodes is 0, and the maximum number of nodes, we're going to set that to 2. And the idle seconds to scale down is 120. We're not going to bother enabling SSH access for this, and we're just going to create it without any tags just to get going. This compute cluster is going to be required to do the processing for our regression tests. While that's completing, what we can do is we can pop over to the designer, and we're going to create a pipeline in the designer. So we're going to click on design on the left hand side, and we're going to create a new pipeline using some classic pre-built components here. And underneath component, we're going to look for a specific type of data. We're going to look for this automobile price data. Microsoft provides us with some default data we can play with, and we're going to use this. We're going to drag this onto our canvas here, and this is what we're going to use to play with. Let's go and have a look at some of the preview of this data. If we look at this preview data by right-clicking on it and preview the data, we have here, let's expand this a little bit, a number of columns of data regarding prices of cars. Now what we're going to do is we want to go to predict this price column down here. And this is what our regression model is going to help us with once we've completed it. But notice there's a whole bunch of other columns of data down here. There's also even things like this normalized loss column. Now this has a lot of missing data. So this might be something that we actually want to exclude from our training set later on. So let's just close that for the time being. So now we're going to add another component in here. And this component is going to be the select columns in dataset component. We're going to drag this onto our platform and we're going to connect this automobile price data into this select columns data set. So we've got the data output going into this as a data input. And what we're going to do is we're going to jump into this by double clicking, and we're going to click on edit column here, and we're going to select the columns of data we want to include. So we'll do this by name, and we can see all of our available columns over here. So what we want to do is add all of those comments, but we don't want that normalized losses column. So let's just get rid of that one and save this. And let's just save that selected columns in dataset to return to that pipeline. Closing that down. We're going to add some additional information to this now. We need to clean some data and we need to normalize some data. So we're going to go and look for the clean missing data inside here. I'm just going to drag that one over there. And we're also going to look for another one called normalized data. And we're going to drag that one across. This just allows us to clean up this data a little bit. And we're just going to add in some extra links in here. So we'll take those select columns, link that to clean missing data. And we're going to take that clean data set from the output here and take that into normalizing the data as well. So to configure the clean missing data section, we're just going to grab this, open it up, and in edit column, we're going to make sure we've got bore, stroke, and horsepower selected in here. You can actually just type these options in as well. So if I just delete one of these, we can go type in horsepower, and you'll see, not horsepower, horsepower, and we'll see that is actually going to be auto populated. Save that. We've also got a minimum missing value ratio and a minimum missing value, a maximum missing value ratio. So clean only column with missing value ratio above a specified value, and clean only columns with a missing value ratio below specified. And what we're going to do is, if we actually find anything in bore, stroke, and horsepower that is actually missing data, we're just going to very simply remove that entire row. Very, very simple way of actually cleaning up there. If there's bits missing, just get rid of that column in the data. So let's add that in. That should be saved. And we can go through and look at our normalization data now. Let's double click on that. All right, so what we're going to do with normalized data is we're going to just double click on this one, make sure our transformation method is set to a min-max logic for normalizing this data. And we're going to add in these specific columns. I'm just going to Control V and paste a bunch of stuff inside here, just to normalize the rest of the columns that are available to us. So I'm going to just paste in a bunch of columns here. These are the columns. Oops, hang on. That didn't quite work right. I need to put some commas in those. All right, that's now pasted incorrectly. So we've got some of our columns that are going to be included inside our normalization. Let's go and save that. And we're also going to go and save this entire pipeline. So our pipeline looks okay. We're getting some of this raw data come through. We're selecting the specific columns we want, getting rid of the one we didn't want to actually deal with. We're cleaning some of that missing data, right? And that's also, we're going to normalize that data too. So now we should be able to configure and submit this pipeline job for some training. So let's go and configure this. We are going to create a new experiment. I'm going to create this experiment called auto price. And our inputs, we're going to specify here. Go back to basics, hang on. We're going to select our compute cluster to run this on, and we're going to put this into our Workspace blob store at the end. And hopefully we should be able to submit that job. Our pipeline job has been submitted. It should start to run. The submission pipeline run has succeeded now. And we can go and view the details of that up here in the top left. And let's have a look at our job. Let's get rid of some of these options down here. You should see that this is currently running for selecting columns, and it will move into clean missing data, and it will then move into normalization of data at the moment. So this pipeline is currently executing for us. Let's just wait for that to actually crunch through. Alright, so let's go back and have a look at our pipeline here. This job is now completed, and we can see on the normalized data, if we go and preview this data and preview the transformed data set, let's expand this out a little bit. All of our data has been nicely cleaned up, which is great. And we've also got normalization on our data for things like length, width, height, curve weight, and engine size, bore, and so on and so forth. So our data is ready to work with, to go and build one of our machine learning models on. So I'm just going to return back over to our designer, and we're going to go into that pipeline designer here. And to do our model, what we need to do is just maneuver this around a little bit, make it a little bit neater, sort of neater. We need to go and split our data. So we need to go and have a look for a split data module here. And we need to take some of our data to be live data, or the data that we're going to use to train the model, and some of our data that needs to be done for testing the model. And we also need to actually go and randomize that data as well. So we'll take that split data module down here, and what we're going to do is we're going to connect this to our transformed data set here on the left hand side, and we're going to output that into this input over here on split data, and we're just going to make sure that all of these settings are correct. Let's change this fraction rows off to 0.7. The randomized split needs to be true. The random seed will use 1, 2, 3, and the stratified split will leave that in false down there as well. We'll just knock that off to the side down here. So that should select about 70% of the data for training and about 30% of the data for testing and validation of our model. So in this asset library, we're going to search for and place a train model onto the canvas as well. Let's do a train model down here. We're going to grab that and bring this over here. And then we're going to take this output data set here and pop that into the input of the train model. Now, we are training this model on the column of price. This is what we're going to actually attempt to predict. So let's go and save that. This needs to be case sensitive as well. And the way we're going to do this training model is we're going to actually use regression. So let's go and find a regression section down here. Let's do some linear regression. I'm going to drag this over here. And what we're going to do is we're going to attach this linear regression untrained model into the input here of this train model. Now we also need to make sure that this outputted data is going to be correct. So we're going to go and grab a score model from here and drag this guy over. And this score model, we're going to connect the outputs of the trained model into the trained model of the score model, and the outputs of the split data into that data set. So what the score model is going to do is it's going to take this trained data, and it's going to take this 30% of data from the split data to be able to validate that information to make sure that everything is correct, and that's going to give us our final scored data set. So let's just do a review of that pipeline again. We have some raw automobile price data that's coming in. We're sub-selecting some columns. We're cleaning out any missing data. We're normalizing some data down here. We're splitting this into data that's going to be used for training and data that's going to be used for testing. We're going to train this model by using linear regression. And then we're going to actually pass the outputs of this trained model to test it against the existing test data that's coming from the original data set there that's been split. So let's go and configure and submit this pipeline. And we'll select an existing experiment of auto price. We'll leave this as a basic job display name. I don't need to change anything down here. We don't need to change anything our inputs and outputs. We are going to use our existing cluster that we built. We're going to go next on that one, and we're going to submit this. and we're going to leave this to run. It's going to take a few minutes, might take 5 or 10 minutes to actually run through and process this data and spin up the appropriate machines to do it. Alright, so our pipeline is now complete. Let's go right click on the scored data, preview this data, and have a look at the scored data set. So this is all the complete scored data. So we've got a scored labels column down here, and we were going to predict our pricing. What we need to do is we need to establish how reliable these predictions are. And to assess this, we need to go and evaluate this model. So from this price data and these scored labels, we need to evaluate this model to make sure that it's actually accurate. One way of evaluating a regression model is to compare the predicted labels to the actual labels in the validation data set that we held back during training. So what we're going to do is we're going to just drop in here onto our pipeline. We're going to go back into our designer. Let's go back into our creative pipeline down here. And we're going to add something on the bottom of this. We're just going to add an evaluate model. And we're going to drag that in here and take that scored data set and attach that to our evaluate model down there. And we're going to attach that to this scored data set entry point here. And we're going to resubmit this job and see what our evaluation actually comes back with. So configure and submit. Next on that one. Compute cluster, Grammar ML cluster, that's good. And we will submit that job for another run. So let's wait for that to actually complete and we'll see what our evaluation model actually spits out. So now that's created and the pipeline's finished running, we can go and have a look at the evaluation model, preview that data and preview the evaluation results. And we can see we have our mean absolute error, our root mean squared error, our relatively squared error, and our relative absolute error, and our coefficient of determination. Each one of these is telling us that, well, roughly this model looks pretty darn accurate. I mean, if you take something like the relative square error here, and we've got 0.082301, is that good? Is that bad? Well, if you look at something like this, how to actually calculate the relative square error, if the RSE is lower than 1, then the predictive model performs better than the simple model, i.e., in other words, the error of the predictive model is smaller than the error one obtains by simply using the mean as the predictor. So this is actually producing more accurate information than just literally averaging out the data. TLDR, our model here is good. So what we need to do now is create and run something called an inference pipeline. And this inference pipeline will allow us to add data into this model and retrieve some information out of this. So we're going to go into the job section down here. And these are all the jobs that I've actually run. So here's my auto price and my latest job that's actually defined inside that. And what we're going to do is going to jump into auto price down here. And we can see these are those pipeline jobs that I actually ran before. Alright, so here in the jobs details section, we need to create an inference pipeline. The problem is this should be up here, but they appear to have messed up the interface slightly. So if we just hide this outline, you can see it pops up. And from here, we can go and create an inference pipeline. And we can go and choose a real-time inference pipeline. And a new version of our pipeline named the auto price training real-time inference should get opened in a minute, just after this locks up for a second. Alright, so this has created an inference pipeline for us with a web service output and a web service input. We're just going to go and edit this and rename it to predict auto price, and we're going to save that. Alright, so one of the things that this has is the original automobile price data. Now this still has our price list in it, and we want to get rid of this because we want to input our own data to be able to predict price. So we're actually going to delete this, and we're going to insert a new section called enter data manually. This will allow us to actually input our own CSV data into this model, and we'll link this back to the select columns in that data set. Now what we can do is we can come in here, go to the parameters of this data, whoops, open this up, CSV, and we're going to go and paste this data directly in. Now I have some of this data already available, and I'm just going to throw this directly in there, and this is some of my normalized data that we're going to try and predict prices off for specific cars, in this case the Alfa Romeo convertible and the Alfa Romeo hatchback. I'm going to save that. I'm going to just pop this over to the side, and we don't need that displaying anymore. Let's just pop that in. Now what we also need to do is get rid of that price field further down the line here. So let's go into select columns dataset down here, and let's just go and edit this column. We'll just make sure that we don't actually have price included here on this column, and save that. Get rid of that on the side there and slide that back in again. Now the other thing we don't need from this is the evaluation model. We've already taken a look at that, but this is not what we need at the moment to go and run an inference pipeline and actually import new data, so we're going to get rid of that component too. Now also remember, this outputted score model also included all of the input features of the predicted label. So we're going to make a little bit of a modification to this as well, just so it neatens up the data on the output. So let's get rid of this connection here. And what we're going to do is going to insert a little bit of Python magic. So we're going to execute a Python script here. And we're actually going to execute a Python script to insert some pandas data frame information. So we're just going to take all of this code here, get rid of it, and we're going to drop in our own code down here. So this is going to import pandas as PD. So pandas is a Python library that allows us to manipulate data for data analytics. Really, really useful. So things like pandas and another one, PyTorch and NumPy, these kind of things are used pretty regularly in machine learning. This is going to take our scored results and actually rename our scored labels and our predicted price down here. So let's go and save that and just drop that out there as well. Just going to connect these scored data sets from here in the scored model and connect that into the dataset 1 of the Python script, and just execute the output to that web service output as well. Just neaten all that up a little bit more. Right, so let's now submit this inference model and see what we get on the output of this. So we're going to have an existing experiment. It's called auto price. The job display name is going to be called predict auto price. That's fine. And we're going to fire this through our compute cluster that we've built before. Let's submit that job. And again, we need to go and wait for this job to actually complete and crunch along. So that's currently loading that job into the pipeline. Sorry, loading that pipeline in as a job. And we'll come back to this in a moment. So that job has been submitted. Let's go and view the details of that job down here. It's going to open up a new window again. And we're just going to check that this job is actually running, and we can see that things are processing accordingly. We just have to wait for it to crunch the numbers through all of this inference pipeline here. All right, so our pipeline's completed. Let's just go and have a look at this enter data manually section again. Let's have a look at the preview of the data. This is what we threw in via a CSV file earlier. There's 3 Alfa Romeos here with various different statistics of curb weights, engine types, fuel systems, horsepower, peak RPM, ages, that sort of thing. And what we've done is we're going to run that data all the way through this pipeline structure here, and our final execute Python script will allow us to see the outputs of that data. And here is that predicted price for each of those Alfa Romeo cars. Now we know that our model is actually working. What we need to do is actually deploy this so other people can actually use it. For example, send data to it via a REST API and be able to retrieve some outputs from this model or predicted price data from this model from inputs that they provide. So let's just close off all of these services here. And what we're going to do is we're going to actually go through to deploy a model. So to do this, I'm going to press this deploy button at the top here, and I can deploy a new real-time endpoint. And I'm just going to call this real-time endpoint predict auto-price down here. And this is going to be a description of automatic price regression. And the compute type, we can go throw this up as an AKS compute node. So this will be a full Kubernetes cluster, which might be a little bit overkill, but I haven't got a Kubernetes cluster either. So I'm going to throw this up as an Azure Container Instance and actually deploy this model right now. So it's going to take a while to actually deploy Container Instance. It normally takes up to about 5 minutes to go and build this. What we can see it's actually monitoring up here, but we'll wait for this Container Instance to actually deploy. So our endpoint predict auto price model deployments is completed on its deployment. If I drop over into my container instances section, we can see that this is actually running inside my resource group of machine learning. It's running in EastUS, it's on Linux, and it's ready for me to interact with. Now I can actually communicate this on its FQDN if I wanted to, but what we've actually got down here is the ability to click on endpoints, and we can see this endpoint listed directly here, or see this container instance directly here. We can see this operation state is succeeded and this deployment state is healthy. It took probably about 15 minutes or 20 minutes to actually deploy this. What I can now do is I can test data with this. I can actually start feeding some information into this. So here's some test data that's actually going in, or at least the 3 elements that I was inserting earlier. If we go and test that, you can see the existing predicted price outputs. Now we can go and change this data around if we really want to. So for example, I could take a different stack of JSON data, just Control A, delete that, paste some more in here, and go and test that information down there. So we can see I've got a different Alfa Romeo down here. It's a body style convertible, rear wheel drive. Let's go and change a couple of these things around. Let's give this not a bore of 3.47, let's give this a bore of 647, and let's say that this city MPG is maybe 51 and its highway MPG is 77. That's an insane MPG, and go and test that information as well. And we can see that we're actually getting a better predicted price for this. Well, of course, I'd pay a lot more money for something with that kind of city and highway MPG on here as well. So you can go and play about with these models yourself, and you can start to get sort of outputs down here. We could use this as a basis for building additional applications. We'd of course want to build some sort of front end for this, where we can get people to actually insert this data rather than through a JSON through some sort of nice UX or some nice GUI interface. And that kind of brings us to the conclusion of doing a very basic, essentially, design of a pipeline. So just to recap on here, we created this predicted auto price pipeline down here. Actually, let's just rewind to this point. And what we did was we got some automobile price data, some base data that we already have, had in CSV, pulled all this in, filtered the data out, split the data out into testing data and training data using a 70-30 split, evaluated that model to make sure that the data that was coming back or the results that it was producing were accurate or more accurate than literally just running an average. From there, we went off and created another pipeline, and we created another pipeline where we could actually insert our own custom data into this model and see how that actually produced through the Python script down here. We use pandas inside our Python script to show the final price data in a very simplistic way. We then converted this and actually deployed this model into a container instance rather than onto an Azure Kubernetes service. And through that container instance, we managed to test this data by throwing more web data at this and more JSON data at this to produce some predicted price information. And again, we can go and change this around to say maybe the horsepower is 211, the city MPG is 61, the highway MPG is 97 for this first Alfa Romeo down here. And let's see what happens to this price of 14,997, and that price is now 30,398 because it's got a lot more horsepower and a lot more MPG. It's just generally a better car that we're inserting inside here. So I hope you enjoyed this information, and you may join me next time for more on Azure Machine Learning.
And you know the routine, hashtag like and subscribe, and I hope you enjoyed this video and will join me next time.
Goodbye.